Alright, looking at part C, when you're doing tests for symmetry, there are two ways you can test for symmetry. One of them is the algebraic approach. And the algebraic approach, you simply plug -x in for all of the x's. And it's the same test for for y-axis and for origin symmetry. So I start by plugging -x in for the x's. Then we clean it up. 3 times -x cubed will be negative, so -3x cubed. And if you square a -x cubed plus x squared, and then what you want to know is whether this is the same. Is this equal to the original function? Because if it is, it's even. Or is it equal to the opposite of the original function, in which case it is odd? Well, it's definitely not the exact same thing, because my original was 3x cubed plus x squared. I have a -3x cubed plus x squared. So it's not the original. And then negative f of x means you take the opposite of the original, 3x cubed plus x squared, which means negative f of x will be -3x cubed minus x squared, and I don't have that either. I've got -3x cubed plus x squared, so it's not equal to that one either. Therefore, that means this has no symmetry, or it's neither y-axis or origin. So we'll say therefore neither. Alright? So you want it to be either the same as you started or the exact opposite, having a negative distributed. This one, plug in -x. -x to the 4th minus 7, -x squared plus 9. And if you raise a negative to an even power, it will become positive. So that's going to be positive x to the 4th. -x squared is x squared, so -7, and that's x squared plus 9. And you notice when I cleaned that up, I actually did end up with the exact same equation that I originally had. So if f of -x equals f of x, that means we have y-axis symmetry, also known as an even function. And I would accept either answer. If you say even, that's fine. If you say y-axis, that's cool. See, 27, a fraction, that's no fun. F of -x would be -x on top, and then -x squared minus 9 on bottom. Clean that up. -x is just -x. But on bottom, if you square -x, positive x squared minus 9. And in the case of a fraction, notice my bottom stayed the same, but my top did change. If you take any fraction and you only change the top, the sign of the top, so if I take 2/7 and I change it to -2/7, those are opposites. So this actually is the same thing as the opposite of f of x, which makes this thing origin or odd. So for a fractional, or a for a rational function to be odd, you need either everything on top or everything on bottom to change, but no combination. You don't want everything top and bottom to change, just one or the other. Number 28, if I plug in -x, this one's going to be really quick, because that would just be 1 over -x. And again, like I was saying earlier, if you take a fraction and you only change the sign of the bottom, that is the opposite of the original. So this is -f of x. So again, we have origin symmetry, or if you want to call it odd, I'm okay with that too. I'm okay with that. 29, tangent x. Now this is one where doing the algebra test is going to be a little bit trickier, because you have all forgotten your unit circle. You've all forgotten your trig identities. So what I'm going to do for tangent x is I'm going to think of this one graphically, and what I know about tangent x is that you have a vertical asymptote at positive pi over 2 and a vertical asymptote at negative pi over 2. It's kind of a crap graph, but I'm just kind of visualizing this, because some of these are easier to think graphically. And I know that my graph's going to come up through the origin and then go back up. And I can look at that graph and I can tell that that is origin symmetry. And the real test is if you can take the graph and rotate it 180 degrees, if it stays the same, that is origin symmetry. And notice it ended up having the exact same shape, whether you've got it right side up or upside down. So that is origin symmetry. And I'm going to avoid the algebra test on this one. And I'm just going to say, hey, the graph tells me this thing is origin or an odd function. 30. F of negative x, ooh, I'll swap to black. 4 times negative x cubed plus a negative x. When you simplify that, that will be negative 4x cubed and minus an x. If I take a negative out of that, that is negative quantity 4x cubed plus x, which is the opposite of the original function. Therefore, this is origin. A lot of origins, also known as odd. Were you good? I don't know, is that the last one? That is the last one. So there are your even, odd, or slash y-axis origin symmetry tests. Yeah, there was only one that was even, wasn't there? Yep, number 26 was it. Okay, well, how exciting.